This is outer space, a timeless source of fascination, mystery, and inspiration. Stretching infinitely beyond our planet, this vast expanse houses celestial bodies like asteroids, many of which hold riches that could shape the future of Earth and its inhabitants, also known as us. Asteroids, often thought of as mere rocky remnants from the early solar system, are turning out to be treasure troves of minerals and resources. Within these space rocks, scientists have discovered an abundance of what are known as rare earth minerals. These minerals, with their unique chemical and physical properties, are integral to numerous high-tech applications and innovations on Earth. Of particular interest is the potential of these minerals in advancing renewable energy production. Rare earth minerals are pivotal in the creation of the powerful magnets that drive the turbines in wind energy generators. Most wind turbines use neodymium iron-boron magnets, which contain the rare elements neodymium and praseodymium to strengthen them, and dysprosium and terbium to make them resistant to demagnetization. Global demand for neodymium is expected to grow 48% by 2050, exceeding the projected supply by 250% by 2030, leaving us with little to nothing in those 20 years in between. The need for praseodymium could exceed supply by 175%, and dysprosium and terbium demand is also expected to exceed supply. Similarly, according to London-based price reporting agency Benchmark Minerals, in order to meet the anticipated demand by 2035 for graphite, lithium, nickel, and cobalt, 384 new mines would be needed. These rare elements are critical to lithium-ion batteries, the so-called white gold that powers electric vehicles and energy storage. They're currently extracted via mining practices that could harm the environment and will likely continue, if not increase, unless we find a more sustainable solution. This begs the question, could mining rare minerals from asteroids unlock advancements in wind energy production, solar panel efficiency, battery storage capabilities, and other green technologies? Its potential to increase rare mineral supplies while also limiting harmful terrestrial extraction surely fosters a positive outlook. So as we gaze into the night sky, we aren't just looking at distant stars and galaxies, but also at potential solutions to some of our most pressing challenges. Outer space, with its asteroidal resources, might just hold the key to a greener and more sustainable future. Just ask Astroforge, a California-based asteroid mining company whose mission is to make space resources accessible on Earth. But Astroforge isn't just bringing the asteroids back down to us. They're going the extra mile by mining asteroids to extract valuable minerals in space at a lower cost and smaller carbon footprint than the current terrestrial mining methods. With the funding support of venture capital firms, angel investors, and Y Combinator, the prestigious US startup accelerator that has helped grow companies like Airbnb, Instacart, and DoorDash, the stage is set for Astroforge's success. And this year, Astroforge is aiming to reach new heights. Literally. In May 2022, it closed a $13 million seed round to jumpstart its vision to become the first commercial company to mine an asteroid in outer space and bring the rare minerals back to Earth. Announced on January 24, 2023, it made plans to embark on two important expeditions: a refinery demonstration that puts its technology to the test in space, and a deep space mission to observe one of its target asteroids. The first expedition took place in April 2023 aboard a SpaceX Falcon 9 launch in partnership with satellite and in-orbit service provider Orb Astro. The objective of this mission was to validate its technology and perform extractions in zero gravity using a cube satellite called Broker 1.
Orb Astro AF1 separation confirmed.
The Falcon 9 spacecraft launched preloaded with an asteroid-like material that the refinery payload aimed to vaporize using a laser. The goal was that once vaporized, the refinery payload would collect the vapor and sort it for platinum group metals, or PGMs for short. The Astroforge team is starting with these PGMs, which are found on both asteroids and on Earth. the leading theory being that we only see them on Earth's crust due to asteroid impacts millions of years ago. But with Earth's supply running low, these rare elements have increased in value greatly. As traded commodities, they range from $400 to $20,000 per ounce. Astroforge wants to make sure that it's bringing back just those rare minerals that are worth a lot of money, because bringing back is still expensive since weight in space means a lot. Hence its decision to start with the valuable PGMs. It even has an ambitious goal of building a larger spacecraft in the future to bring back between 1,000 and 2,000 kilograms of PGMs per mission, potentially returning $70 to $140 million in cosmic bounty. From a private company standpoint, this makes a lot of sense. Astroforge co-founder and CEO Matthew Gulich states that their current funding has been able to fund their first 2 expeditions. Both are largely research-based with the intention of proving to investors that their technology and vision are worth putting their money into. Astroforge's second expedition is set for Q1 2024 aboard a SpaceX lunar rideshare with lunar-focused aerospace company Intuitive Machines, in-space propulsion company Dawn Aerospace, and continued partnership with Orb Astro. The goal with this expedition is to observe a target asteroid using a survey spacecraft called Broker 2 in preparation for its first retrieval expedition. This will entail a flyby of the asteroid, capturing data and 20 megapixel images as Astroforge seeks to confirm metallic riches. Intuitive Machines will help them get much of the velocity needed to reach the asteroid, and it'll rely on Dawn Aerospace's propulsion system to make the rest of the journey. Like Astroforge, even national space agencies are taking an interest in asteroids. Both NASA and the Japanese space program have already conducted 3 research missions with similar profiles, but without the mining. Actually, just on September 24, 2023, in America's first asteroid sample return mission, NASA spacecraft OSIRIS-REx returned from a 7-year-long mission and delivered a sample of rocks and dust from the surface of a near-Earth asteroid named Bennu. The mission had actually been in the making for 12 years, having first been selected in 2011. If a place like NASA has that much dedication to sampling one asteroid, it just goes to show the promise of exploring these celestial bodies further. And not to take away from the monumental expeditions that Astroforge has embarked on, but the concept of asteroid mining isn't new. In fact, it's actually been around for over a decade. A US startup in 2012 called Planetary Resources set out to expand Earth's natural resource base by developing and deploying the technologies for asteroid mining.
Everything we hold of value on Earth, metals, minerals, energy, real estate, are in near infinite quantities in space. Our goal is to prospect, claim, and extract resources from near-Earth asteroids.
Before long, a competitor called Deep Space Industries appeared on the scene. With all-star cast of founders and investors, and compounded by a lot of media hype, the industry of asteroid mining showed abundant promise at the time. However, it was quickly disregarded as investors determined that these companies weren't able to deliver, largely due to the high cost of launch alone compared to the cost of simply extracting the same rare minerals on Earth. Henry Hertzfeld simplified it like this: the bottom line is that space is hard. It's risky, it's expensive, lots of high upfront costs, and you need money. You can get just so much money for so long. They didn't generate the revenues, and there's a limited amount of time for a company to exist without a profit. So how is Astroforge convincing the same investor base just 10 years later? In that relatively short span of time, technological advancements have been made by other players within the broader space economy, and companies within are leaning on one another to achieve their own objectives. Among the most relied upon technological advancements is SpaceX's rideshare program called SmallSat, which started in 2019. This rideshare option leverages SpaceX's reusable Falcon 9 to offer a consistent, more affordable way for small satellite operators to put lighter payloads into orbit. revolutionizing the price to get to outer space. The rideshare program operates on a defined schedule and is designed somewhat like the rideshare programs here on Earth. Passengers who are ready get to ride, and SpaceX looks to fill seats by offering bookings both in advance, in this case, 12 or more months out, and much closer to launch time, in this case, between 6 to 12 months out, priced according to the payload mass intended to launch. And of course, this is where we deviate from the Uber model. A 200 kilogram payload amounts to an estimated $1.1 million. And for companies within the space economy that operate with costly research, development, and engineering, this is actually very cheap. The rideshare program is leveraged by the space economy overall, including NASA, Astroforge, and its collaborators. It seems that the US government would have a very big interest in what Astroforge is doing for national security reasons. So why don't they just give them $250,000 and a contract to make sure it works? Because if it does work, this would be monumental for national security, since the US would no longer be in competition for rare earth minerals with other parties internationally.
I think we could talk about governments and how they work all day long and where the money gets allocated to. At the end of the day, I need to show that I'm a profitable company with or without the government's help. I want to be a commercial space company.
This is a foundational principle of venture capital. As Gulich sees it, venture capital is about taking big risks for big payoffs. And that's exactly what companies like Astroforge are as players in generally uncharted territory, both theoretically and physically. Elon Musk built out SpaceX successfully enough to show investors that there was a pot of gold at the end of the rainbow when it came to investing into space companies. And at this point, it isn't just SpaceX. With greater technologies and wider acceptance of the space economy, other space companies have been able to mature to the point where a company like Astroforge could buy the components needed for its expeditions rather than manufacture them themselves, saving them a ton of time and money and making the promise of delivering to their investors that much more achievable as a result. For instance, Astroforge's Q1 2024 expedition will again partner with Orb Astro, who has built a spacecraft in close coordination with Astroforge to integrate their software and overall vision, a huge time saver and a big reason why Astroforge is moving so quickly. 16 months after its inception, the company was already in outer space. Cost-wise, at less than $10 million, Gulich says, the mission will be 2 orders of magnitude cheaper than anybody's ever attempted before. So as the global community pushes towards a renewable energy future, the importance of these rare minerals cannot be overstated. Yet with dwindling reserves on Earth and increasing environmental concerns tied to their extraction, the prospect of asteroid mining is not just about exploration, but also about preservation. Tapping into the mineral wealth of asteroids could offer a sustainable way to meet our energy demands while safeguarding our planet's ecosystems and our well-being as its inhabitants. With new technological advancements making asteroid research more tangibly possible in the near term, and the growing support of investors, private companies are certainly jumping on the opportunity to trailblaze the asteroid mining industry. The interconnectedness of the space economy only makes its players stronger, and Astroforge's mission is one that has surely earned our attention.